Lesson: NLP for Threat Intelligence. Natural language processing has revolutionized various fields, including cybersecurity. In the context of threat intelligence, NLP provides powerful tools to analyze and interpret vast amounts of unstructured text data, such as threat reports, security blogs, and social media feeds. This ability to process and understand human language enables cybersecurity professionals to detect, analyze, and respond to threats more efficiently. Threat intelligence involves gathering and analyzing information about current and potential threats to an organization. This information is often contained in textual formats, making NLP an essential tool for extracting actionable insights. NLP techniques can identify patterns, extract relevant entities, and even predict future threats based on historical data. For instance, by analyzing past cyber attacks' text descriptions, NLP models can learn to recognize indicators of compromise and predict similar future events. One of the primary applications of NLP in threat intelligence is entity recognition. This process involves identifying and categorizing key entities within a text, such as IP addresses, domain names, malware types, and threat actors. Named entity recognition models, trained on large datasets of cybersecurity-related text, can automatically extract these entities from unstructured data, significantly reducing the manual effort required by analysts. For example, a study by Spasi demonstrated the effectiveness of NER models in extracting threat intelligence from text data with high precision and recall rates. Another critical application is sentiment analysis, which can gauge the sentiment expressed in texts related to cybersecurity threats. Sentiment analysis can help prioritize responses by identifying texts that express urgent or severe threats. For example, a tweet suggesting an imminent cyber attack could be flagged for immediate attention. Sentiment analysis models, trained on labeled datasets, can classify texts as positive, negative, or neutral, providing valuable context to threat intelligence analysts. Moreover, NLP can enhance threat intelligence through topic modeling, a technique used to discover abstract topics within a collection of documents. Topic modeling algorithms, such as latent Dirichlet allocation, can automatically identify themes and trends in large sets of cybersecurity texts. This capability allows analysts to quickly understand the main topics discussed in threat reports, security blogs, and other sources, helping them stay informed about emerging threats. For instance, a study by Bly et al. Demonstrated the effectiveness of LDA in uncovering hidden topics in large text corpora, which can be directly applied to threat intelligence. Additionally, NLP can be used to automate the extraction of IOCs from unstructured text. IOCs are critical pieces of information that help detect and respond to cyber threats. By leveraging NLP techniques, such as regular expressions and machine learning classifiers, IOCs can be extracted from texts with high accuracy. For example, a research paper by Ju et al. Presented a system that used NLP to extract IOCs from threat reports, achieving significant improvements in extraction accuracy compared to manual methods. The integration of NLP with machine learning algorithms further enhances threat intelligence capabilities. Machine learning models can be trained on historical threat data to predict future threats and identify patterns that might be missed by human analysts. For instance, deep learning models, such as recurrent neural networks and transformers, have shown great promise in processing and understanding complex text data. A study by Vaswani et al. Introduced the transformer model, which has become a cornerstone in NLP due to its ability to handle long-range dependencies in text, making it particularly useful for analyzing detailed threat reports. Furthermore, NLP can improve the efficiency of threat intelligence sharing. Standardizing the language and format of threat reports using NLP techniques allows organizations to share threat intelligence more effectively. This standardization ensures that critical information is communicated clearly and consistently, enabling quicker and more coordinated responses to threats. For example, structured threat information expression is a standardized language for representing threat information, and NLP can be used to convert unstructured threat data into STIX format, facilitating easier sharing and integration with other security tools. The application of NLP in threat intelligence is not without challenges. One significant challenge is the need for high-quality, labeled datasets to train NLP models. Creating these datasets requires substantial effort and expertise, as the labeling process must accurately reflect the complex nature of cybersecurity threats. Additionally, the dynamic nature of the threat landscape means that NLP models must be continuously updated and retrained to remain effective. Despite these challenges, the potential benefits of NLP in threat intelligence make it a worthwhile investment for enhancing cybersecurity. Another challenge is the interpretability of NLP models, especially those based on deep learning. While these models can achieve high accuracy, their decision-making processes are often opaque, making it difficult for analysts to understand why a particular threat was identified. Improving the transparency and interpretability of NLP models is an ongoing area of research, with techniques such as attention mechanisms and model-agnostic interpretability methods showing promise in making these models more understandable to human analysts. In conclusion, NLP plays a crucial role in enhancing threat intelligence by automating the extraction of valuable information from unstructured text data. Through entity recognition, sentiment analysis, topic modeling, and IOC extraction, NLP enables cybersecurity professionals to detect, analyze, and respond to threats more efficiently. The integration of NLP with machine learning further enhances these capabilities, allowing for more accurate predictions and pattern recognition. While challenges such as dataset quality and model interpretability remain, ongoing research and development in NLP continue to drive advancements in threat intelligence, making it an indispensable tool in modern cybersecurity.